Hey YouTube, and welcome back to the channel. Today we are talking about the system design of a social media newsfeed system like Facebook. We will talk first about the functional requirements and non-functional requirements, and we start right ahead on the high-level design that you might face in system design interviews. So, in terms of the functional requirements, we need to design a system that the user can create posts containing text, images, and videos. We also want to have like the user can follow other users. Also, the user can view a personalized newsfeed consisting of relevant and recent posts for people they follow. Users can like and comment on the post. New post should appear in the user's feed within a few seconds. And also, the system must handle users with very large following, such as celebrities or influencers. And in the non-functional requirements, we need to make it scalable, available, low latency, and we will accept some sort of eventual consistency. So there is key features here we need to think about. Like for example, the user can create post containing text images. So that means that we will have a post service, and since we did talk about a service can have can contain a post can contain image or video. That means we'll use like object storage, something like S3. There is other key thing how here we need to think about when we said that user can view a personalized news. That means that we have to establish a new like I'll say that an what was the word for it? I forgot the word for it. It was the engagement service. Sorry, and also a new service. These services will give us all the functionality that we need. The thing that in functional requirements, it gives you a keywords of what services you have to actually create. Okay, so this is a design. This is a high-level design of a newsfeed system like Facebook. I will go through it right now. Let's have my pen because we will need it a lot. First, here we have our client. So these represents the end user devices, such as mobile phones and laptops that interacts with the application. They send requests, fetching feeds, posting content, liking comments, and receive responses from the backend. Next, we have our CDN. The primarily used for serving static. It's primarily used for serving static assets and frequently accessed media files quickly and efficiently to users wide world, because it's actually located closer to the user, so all the images will serve quite faster. If you want to know how it works, again, the CDN pulls the content from the object storage, and I guess here we will use like S3 or something like that. When a client requests a media, like an image or a video, the CDN delivers it from the edge server closest to the user, reducing latency and load on the main server. Next, we have here our object storage. It's a scalable and highly available storage solution for unstructured data, specifically media files like images, videos, audios, things like that. Example, I guess we can use Amazon S3 or Google Cloud Storage. How it works, basically, when a user uploads a media file, it's stored here in this storage. The media service, which this service interacts with this storage, and the CDN caches it and catch its content. Next, we have the load balancer or API gateway. This is the entry point for all client requests into the backend services. It performs several critical functions. First, it's distribute incoming requests across multiple instances of the backend services. We have here media service, user service, engagement service, etc. Second, also it can act as an API gateway. It can also act as an API gateway, handling concerns like authentication, authorization, rate limiting, request routing, and potentially transforming requests before forwarding them to the appropriate microservice. So first, we have the user service. The purpose of it, it's a dedicated microservice responsible for managing user-related functionalities. The functionality of it handles user registrations, login, profile management, authentication, and potentially aspects like user search. Next we have before I talk, it interacts with two databases. It stores. We have a user database here. This one here. This stores user information like username, password, which is hashed, of course, and profile data. It also interacts with follows database, stores the relationship between users, who follows whom. This is crucial for building a personalized newsfeed. And also, I will say something. In a bit, I will talk about which type of database we are going to use, but this will be in the end. First, I will talk about the services. Next, we have the engagement service. The purpose of it is a microservice dedicated to handling user engagement interaction on a post. The functionality of it processes like, comments, share, and potentially other interactions types. It interact with the comments DB, basically, and the like DB. The likes DB stores information about which user liked which post, and the comments DB stores user comments associated with posts. Next, we have the post service. So a purpose of it's a microservice responsible for handling all operation related to posts. The functionality of it allows users to create new posts, retrieve existing posts, editing posts, and deleting posts. You can perform CRUD operations on the posts. It interacts with the post DB, which stores the core data of the post, like text, content, metadata, links to media. And also it interacts with the message queue, which publishes events to the message queue when a new post is created or updated. This is a key part of asynchronous event-driven architecture. Next, we have the media service. It's a microservice especially for handling media-related operations. The functionality of it manages the upload, processing, or resizing, transcoding, and retrieval of media files. It acts as an intermediary between the post service or other services needing media and the object storage by itself. It interacts with the object storage, stores and retrieves the actual files data. Here we have our message queue. The purpose of it's a transient storage for messages, enabling asynchronous communication between services. Example, I guess we can use like Apache Kafka or RabbitMQ or maybe Amazon SQS. Basically, if you want to understand how it works, like when a post service creates a new post, for example, this post service creates a new post, it publishes a new post event to the message queue. This decouples the post service from the feed service. The benefits of it allow asynchronous communication or asynchronous processing. The post service doesn't have to wait for the feed service to process the new post immediately. It also has some sort of decoupling because services don't need direct knowledge of each other, making the system more flexible and resilient. Also, it's scalable because it allows services to consume messages at their own pace and scales independently. Lastly, it's quite reliable. Messages are persistent until consumed, ensuring delivery even if a consuming service is temporarily down. Next, we have the feed service. It's the purpose of it's a critical microservice responsible for generating personalized news feed for users. The functions of it's consume messages from the message queue. When a new post event arrives, the feed service processes it. It have some sort of fan out, like for a news feed. This likely involves fanning out the new post to the feeds of all followers of the post's author. This can be done like via a push model or a pull model. I will talk about what is a push model and a pull model. If you don't understand what is a fan out and what all of this means, I will create a video for each one of them because I guess they needs a video on their own, only on their own. And next it has some sort of personalization and ranking because it applies algorithms to rank and filter posts based on user preferences, engagement, and other factors to create relevant feeds. It interacts with the feed cache, which stores pre-generated or frequently accessed user feeds to serve them quite quickly. We have here the feed cache. The feed cache, it's a high-speed data storage layer that stores frequently accessed data, reducing the need to hit the primary database. Example, I guess, example includes like Redis or Memcached to use as a feed cache. If you want to understand how it works, the feed service populates the feed cache with pre-computed user feeds. When a client requests their news feed, the feed service first checks the feed cache. If the feed is present and fresh, it's served directly from the cache, significantly improving response times and reducing load on the database. Okay, I guess we need next to talk about the databases. Okay, so in terms of the user service, I guess like here we have user profiles, which is maybe username, email, password, which is hashed, bio, profile picture, potentially settings. This data is highly structured and has clear relationships. We need a strong consistency for user accounts. You don't want user passwords to be partially updated. Sorry. I guess so. We will use a SQL database for that. Maybe you can use Postgres or something like that. And also in the follows DB, we can use also Postgres. This is interesting because while you could store follows on a relational database with a simple follow ID and follower ID and follow ID table for every large scale social, we can have like a graph or something like that, or we can use ArangoDB. I guess could be incredibly efficient as well. You can use both, like you can use a Postgres database for the follows DB, or you can use something like a graph database, or you can use something like ArangoDB. I guess it would be incredibly efficient, like if we use the graph database for that, because graph databases are explicitly designed to store and query relationships between entities. However, for a starting point, I guess a relational database can work perfectly fine for follows by just having a table like follows, like follower ID and followed ID, something like that. I guess it will work perfectly fine. Or even you can use like a key value store, whatever you want. But yeah, I guess the follows DB, it's I guess you will have a lot of discussion with your interviewer with it. It depends on the specific requirements that your interviewer wants. What next we have? We have the engagement service. So we have here what we have here, in the engagement service, we have the comment and the likes. Okay, so the likes will have like user ID and the post ID and the timestamp. That's it. And the comments will have maybe the comments ID, the user ID, the post ID of this of the comment belongs to, and the text of the actual, basically the content of the actual comment, and maybe have timestamp. This has clear relationships, but can also be very high volume, like millions of likes and comments per day. The schema is fairly structured, I guess. Okay, so we might use a SQL. Again, relational databases handle the structure. The structure will and provide strong consistency for all individuals like comments. It's easy to query all comments for a post or all likes by user. We can use also alternative Cassandra. If the volume of likes and comments is truly massive, I think we can, like if we think about Facebook scale, you need extreme write throughput and horizontal scalability. I guess Cassandra, which is a wide column store, could be considered. It's designed for handling huge amounts of data spread across many servers, often with an append-only type workload, like new likes and comments are added less frequently updated. You would trade some of the relational query flexibility for raw scalability. In terms of the post databases here, I believe we can use a SQL database or a document database. Why SQL? We can use it because a relational database is a solid choice, as posts have a clear structure and relationships to users. Why we can use like a document database, which is a NoSQL database? I would say if your posts might have a very flexible or evolving schemas, different types of posts with varying fields, like event posts with datas and locations, pull posts with options, and document databases. Like I guess a document database like MongoDB offers more schema flexibility. You can store each post as a JSON document, allowing for easy additions, new fields without any complex migration. Yeah. If I want to talk about the news feed, I guess here nothing like we have. We did talk about the feed cache, so I guess we did talk about all the databases that we talk about, and I guess this was a high level of the system design of the newsfeed system of Facebook. In the future, we might get deep on some components, for example, how the fan out works, for example, how the pull actually works, how to pull the data, how this process works. We will talk about that in video. So yeah, stay tuned and see you in the future.